Welcome! What's up everyone? Tired of making simple straight extrudes in CATIA? Today we're leveling up your 3D modeling skills with one of the most powerful tools, the Drafted Filleted Pad. We're not just creating a volume, we're learning how to control its tapered angle, draft, smooth out its edges with fillets, and master the confusing difference between first limit and second limit. If you want to understand the neutral element setting for good and making your parts look professional, stick around. Let's get drafting.
I got this magic in my fingertips, designing dreams with every click. Shapes and wonders coming to life. With CATIA I cut through strife. In my mind the future's clear. No more doubts, no more fear. Crafting visions in 3D. CATIA's the key, don't you see? I can reach the sky so high. Build my dreams, no need to try. With every tool I sculpt my fate. CATIA helps me innovate.
Hello everyone. Today I want to talk about the drafted filleted tools. The first tool is called Drafted Filleted Pad. With this tool we create an extruded volume at an angle. To get familiar with it, first enter the part environment. Bring the Sketch Base feature toolbar onto the screen. Move the mouse pointer over the black triangle next to the pad tool. Drag and drop the pad toolbar, separating it and placing it on the drawing area. The Drafted Filleted Pad tool is the second tool in this toolbar. Assume we already have a rectangular cuboid on the screen. Now we want to create another rectangular cuboid on top of it. We want this cuboid to be tapered. Click on the surface of the part until it turns orange. Click on the Sketch command to enter the Sketcher environment. Draw a rectangle. Fully constrain it. Change them to trend numbers. Return to the part environment. Click on the command until it turns orange. Click on one of the sides of the rectangle to select it. The Drafted Filleted Pad Definition window opens. Look at the window. There are 4 separate sections in it. In the software's definition window, thin indented lines are used for segmentation. See, when we extruded a sketch with the pad command, the sketch extended along the normal to its plane. After extension, the sketch stops at a specific height. This means that our profile was repeated between 2 parallel surfaces. Here, the lower surface from which the sketch starts is named second limit. The surface at which our sketch stops at that height is named first limit. In the first section of the definition window, first limit is written. Below it, you see length, in front of which there is a framework. You can type any number inside the box. The extrusion of the sketch will be down up to that number. So, this number represents the height of the extrusion. In the second limit section, the surface from which the extrusion operation starts must be specified. Currently, our sketch is on the top surface of part 1. We want to start the extrusion from there. In the second limit section, you see a framework. In front of it, limit is written. This framework has turned blue. Blue color means that I need to do something in it now. The type of action is written inside the framework. No selection is written inside the box. So I must select something. Here I want to start the extrusion from the top surface of the part. So I move the mouse over the surface of the part and click on it. You see that the name of the part surface is written in this framework. Its color also turned white. This means that we did the action correctly. It is important to remember this point. Do not mistakenly think that second limit is the upper boundary of the extruded object. Second limit is the starting surface of the extrusion. The first section of the definition window is called draft. This section includes two parts. The upper part is angle. By default, this section is active. There is a small square in front of it that is checked. In front of angle, there is a framework. A number is seen inside it. This number is the default value. You can type any other correct number in it, even negative numbers. The second part is called neutral element. In front of it, two options are available to you. The first option is first limit. The second option is second limit. These two options refer to the lower and upper surfaces of our pad. Whichever is active, the sketch size is fixed on that surface. The draft moves from the neutral surface towards the second surface by the specified angle amount. The fourth section of the definition window is called fillets. In this section, we have three options. Lateral radius rounds the lateral corners of our pad. First limit radius rounds the edges where the pad meets the upper surface. Second limit radius rounds the edges where the pad meets the surface of the first part. The value for each is written in front of it. Note, if you don't want some of these edges to be rounded, do not enter 0 for the numbers. Instead, just uncheck the box in front of these options. The reverse direction button also reverses the direction. Now I click on cancel. I return to the initial state. Again, this time I activate the sketch first. To do this, I must act from the feature tree. Then I click the command to activate it as well. Its definition window opens. In the length box, I type the number 50. In the limit box, I click on the surface of the first part. Considering that the angle and fillet values are already present in the setting window, the software shows a preview of what will happen. I first uncheck the box in front of angle. I click on preview. It is seen that the extrusion of the sketch became similar to the pad command. So you saw that we can also perform the pad operation with this command. You might say that this pad is now rounded at the edges. It's very simple. I uncheck all the fillet options. You see that it became exactly a pad. Now I check the angle box again. I click on the preview button. If you look closely to the sketch, you see that our upper surface or first limit is exactly the same as the sketch and has the same dimensions. In this case, the lower surface has become larger. The reason is that in the neutral elements section, we define the neutral part as first limit. To apply the 5-degree angle, the software is forced to enlarge the second limit. Note that this angle is measured between the sketch surface and the vertical walls. I uncheck first limit and activate the second limit. I click the preview button. It is seen that the lower surface became equal to the sketch. The upper surface became smaller by applying a 5-degree angle. Now, in the fillet section, I check the first option. I click the preview button. It is seen that the vertical corners all around the shape became rounded. Note that if our sketch was a circle and the extruded shape was a cylinder, then this option would no longer make sense. I activate the second option. This option is first limit radius. It is seen that the corners of the upper surface became rounded. I do the same for the last option. It is observed that the lower corner of my volume became rounded. I click the reverse direction button. It is seen that the extrusion operation was performed in the reverse direction. I rotate the shape in space. It is seen that the height or elevation of the shape became shorter. Can you tell me why? Well, today's lesson ends here. Please watch the lesson twice. Practice with me the second time. Good luck until the next lesson. Goodbye.
Let's build the future. Come with me, don't hold